Hello, everyone. Good evening. Did you all finish the this paper, guys? Did you all finish that? How many marks do you get?
76 or something.
So can you guess what's the average? How many points out of 100 that you got it? 80. No, not 80, not that much. So basically the average is 60 out of 100. Okay. Now let's get started, guys. Because it's time. It's already 6. Okay. Let's get started. Question number 1. This one is pretty easy. How many prime numbers are there in the list, right? And we know that number 1 and number 0, they are not prime numbers. So the first one is not. And except 2, all the other prime numbers cannot be an even number. So you're going to eliminate this one, right? We don't have 12 and this one and this one. You cannot have even number. And then if you take a look at 123, if you add all the digits together, that will be 6, which is divisible by 3. So that's also not a prime number. And 1, 2, 3, 4, 5, that number ends with 5. It's divisible by 5. So it's not a prime number. Okay. And you see out of all these, say 6 numbers, you don't have any prime number. So you choose A, 0. Question number 2. Betty wants to walk from P to Q along the paths shown. Always moving in the direction from P to Q means you cannot go back. She will add the numbers on the path she walks along. How many different total could he obtain, guys? As for this one, you don't need to, count it one by one. Can anyone tell me how can we get the smallest sum if we're going to go from P to Q? You know that in total you have 8 different ways. Because for as for the first one, you got 2 ways over here, right? And then 2 ways and then 2 ways. You have to times them together because you do 3 steps. That means you got 8 different ways. But do we need to list all the 8 different ways and find the total number that we have? We don't need to do that. So the easiest way is that you find what's the smallest sum. That will be 1, 3, 5. Right? That's the smallest sum that we have. 1 plus 3 plus 5, you got a 9. Right? And what's going to be the largest number, largest sum that we can get, guys? Can you type that in the chat box? What's going to be the largest sum that we can get? 9 is the smallest. What will be the largest? 16, we cannot get 16, guys. The largest will be 12. So you do 2 and 4 and 6. That way you're going to have a 12. So 2 plus 4 plus 6, we got 12 over here. And the question is, between 9 and 12, how many different numbers do we have in total? We have 9, we have 10, we have 11, and we have 12. That means at most, you're going to have 4 different numbers, right? So as for 9, we already know that we can get it. And for 12, we also obtain that. But how can I get a 10, guys? Is that possible that I get a 10? It's very easy, right? It's just a 2, 3, 5. That way, you're going to get a 10. So we do 2 plus 3 plus 5. You get a 10. And how about 11, guys? So 11 will be also very easy to get. You do 2, 4, 5 or 2, 3, 6. Okay. So let me just list one of that. 2, 3, 5. That's going to be 11. So that means we can get all of that 4 numbers. So you choose B. Because the smallest is 9, largest is 12. And for the middle 2, we can also obtain that. So that's why we choose B. Next one. So for this question, how many of the following numbers are multiple of 11, guys? What is the divisibility rule for 11? Yes, Kiki, can you tell us?
You do from right to left, but you skip one number each time.
Mhm.
And then so for example, if it's 187,
Yep.
you do 7 add 1, which is going to be 8.
Yes.
And then you take away the total of the remaining number, which is just 8, which is 0.
Yes.
But then if you do 0 divided by 11, it's just going to I
So you
don't
have to
really know,
tell,
but it's
is that-
divisible by.
Yes. Is that 0 divisible by 11? Of course it's divisible, because divisible means when you do the division, you got no remainders. So 0 divided by 11, of course, there's no remainder, right? So the first one, it is multiple of 11. And then the second one, you plus this 1 and 6, you got a 7. And in the middle, it's 5. 7 take away 5, you got a number 2. And we know that 2 is not divisible by 11. So this one is not multiple of 11. And then next one, 2 plus 3 is 5. Take away 5, 0. Okay, 0 is divisible by 11. And then 4 plus 5 is 9. 9 take away 9, you got 0. 0 is also divisible by 11. And 1 plus 2 is 3. 3 take away 3 is 0. So that means this one is also divisible by 11. So in total, except 156, all the others are divisible by 11. Then we choose D. We have 4 of that. Okay. And then next question. In how many two-digit numbers is one digit twice the other? So that numbers comes in pair, right? So the first pair, you could have 1, 2, and then you just swap the order, you got a 2, 1. And then if we add 1 to 1, you get a 2, and another digit must be twice that one, right? So 2 times by 2, you got 4. So you got 24, and you can swap the order. So you got 42 as well. It just asks you to get one digit twice the other. It doesn't ask you like the tens digit must be twice the unit, right? Or the unit must be twice the tens. So you have to swap that. Then you got 2 different numbers. And then you have this 3, 6 and 6, 3. And of course, we can have 48 and 84. Okay, guys. That's all the two-digit numbers. If you got one digit, another one is twice of that. So count it, the answer will be B. You got 8 of that. Okay. And then next one, what is the smallest possible sum of 2 positive integers whose product is 240? Actually, as for this one, you can use the listing method. You just list all the product pairs. When you times them together, you get a 240. So let's try to list them. What was the answer to number 1? The answer to number 1 is 0. There's no prime numbers. Okay, guys, let's go back to this one. So first pair, you do 1 times 240, right? That equals 240. And what's the sum of the two numbers? You see, you want to get the smallest, right? So the sum of this one, of these two will be 241. And then let's go to the next one. 2 times one number gives us 240. You do 120, right? And then how about 3? 3 times what number gives us 240? Yes, 80. And then 4 and 60. How about 5? Is that divisible by 5? Of course, it's divisible by 5. 5 times 48. And then what's next? Do we have 6? Yep, 6, 40. And then 7. 7 is not divisible. How about 8? 30. And then 9, is that divisible by 9? Nope, it's not divisible by 9. And 10, you got 24. 11, you do 2 plus 0 minus 4, it's not divisible by 11. So we have 12. And when you do 12, that'll be 20, right? 12 and 20. And what's next, guys? What's going to be the next one? Actually, the last one. It's also divisible by which two numbers? 15 and 16. Yes, that's right. And you see these two numbers really close to each other. So it means you're going to stop at this place. And guys, actually, you don't need to get the sum of all that pairs because there's a pattern of that. You do 1 plus 240, you will see you got a 241. And then you got a 122. And you got 83. And then you got 64. What's the pattern here, guys? So the sum will get in smaller and smaller, right? So if you want to get the smallest possible sum, you just choose the last one. And that gives you the smallest possible sum. So 15 plus 16, how can we know if a number is divisible by 7? So we'll talk about that later. It's a long story. Okay, Florian. And if you do 15 plus 16, you will see that it equals to 31, and we're going to choose B. Okay. And actually, guys, let's do some conclusion here. If you got two positive integers, they got a fixed product. And if you want to get the smallest possible sum, the closer, I mean, the smaller the difference of that two numbers, then the smallest the sum of that two numbers. You see that 15 and 16, the difference between that two numbers is really small. It's just 1. And that gives you the smallest, the sum of that two numbers as well, when the product is a fixed number. Okay. Does it make sense, guys? You can tap 1 if you understand this kind of conclusion, this kind of rule. So guys, let me give you a new question. Let's see if I tell you two positive integers and you times them together, you got 12. What's going to be the smallest the sum you can get? Can you tell me directly what's going to be the smallest the sum? As for the yes, Eric, that's right. It's 7. Because just as we said, you have to find two products that they are really close to each other. And that way you're going to get the smallest sum. So we have 3 times by 4, which equals to 12, right? And 3 plus 4 equals to 7. And that's the smallest sum we can have. Of course, you can check it. If you do 1 times by 12, right? You see that two product, the difference of that two is very large. And the sum of that going to be large as well. 1 plus 12, you got 13. It's much larger than 7. Okay, so 7 will be the smallest. Next question. Okay, this one is a little bit hard. What is the last digit of the smallest positive integer whose digits add up to 2019? Actually, for this one, if you want to get that number as small as possible, you need to include as many as 9 in it, right? Because the largest unit digit, I mean, single digit number is 9. So you have to see how many of 9 do we have in this 219? Because you add all the digits together, you're going to have that number, right? So we have to use this 2019 divide by 9. And actually, you don't need to do the calculation because, guys, we want to get the remainder. If that is divisible by 9, means the last digit must be 9, right? So, guys, if you do 2019 divided by 9, what's the remainder? Does anyone still remember that? There is a tricky way to get the remainder when you divide by 9 and 3. So basically, you just add all the digits together, divide by 9. The remainder will be the same when you use that original number, divide by 9. So 2 plus 0 plus
3.
1 is 12, right? 12 divided by 9, you got 1 with remainder 3. That means if you do this kind of calculation, the remainder will be 3 as well. Okay, someone please get muted. And that means you got a lot of 9s here, right? Just list a lot of 9s, and you got 3 more, 1 more 3. So guys, should I put that 3 at the very beginning at the very beginning of that number or at the very end of the number to make that number as small as possible. Guys, beginning or at the end. At the beginning, right? So actually you can compare these two numbers. If you got 9, 9, 9, and 3, and 3, 9, 9, 9, of course, the second one is smaller, right? So we need to get the smallest number. That means you start with a 3 and followed by a lot of 9. And that way, the last digit of the number will be 9 over here, right? So you choose E as the correct answer. And of course, if I change the question to what will be the first digit of this smallest positive integer whose digits add up to 2019, then the answer will be 3. Okay. Next one. So the product of 3 different positive integers is 24. What is the largest possible sum of these integers? Also, for this one, you can use the listing method. You can use the listing method. Let's see, 3 numbers times together to get 24. Let's see if we got 1 in it, that means another 2 numbers times together, you need to get this 24. Okay, Cindy, we'll go back to that question after we finish all the questions. Question number 7, right? Okay. Let's see. 1 times what number times what number, you got 24. It says the product of 3 different. So you cannot have another 1 over there. So it can be a 2, and you do 1 times 2 times 12. And then we do have this 1 times 3 times by 8. And then 1 times 4 times 6. Yep. And we finish all the pairs if you start with 1. And then let's see, we have this number 2. If you have 2, you cannot have 1 anymore because we finish all the combinations start with 1. So you do 2 times 3 times 4. That will be 24 as well. And I guess that's it. That's all the combinations you can get a 24 using 3 different positive integers. And now you just add them all together, see which one is the largest. So for the first one, 1 plus 2 plus 3 plus 12, you got this number, say 15, right? That's the sum. And then 1 plus 3 plus 8, you got 12. And then this one, 11. And this one, 2, 3, 4, that'll be 9. So 15 will be the largest. And then we choose D. Okay. Okay, I think 3 of you asked a question about number 7. So let's go back to this one again. I'm going to explain this again. Let me erase this. Because that 2019 is a large number, how about we change that into a smaller number? Let's see 54, 55, how about that? So guys, question, what is the last digit of the smallest positive integer whose digits add up to 55? How do you solve that question? If you want to get that number as small as possible, you have to use as many of 9 digits that you use in that number, right? So you have to figure out how many of 9 do we have in 55. You use 55 divided by 9. Guys, tell me how many of 9 can we have at most in that number? Yes, you got a 6, which is remainder 1, right? So that means the number you got will be, you have will be 6 of 9 and 1 of this remainder 1. And you want to get that number as small as possible. So where should we put that 1? Should we put that 1 at the end or at the beginning? So you have this number. So is this one smaller or is this one smaller? Of course, the second one is smaller, right? That's why the last digit of that number is 9. You see, if you add all the digits together, 6 of 9 will be 54, and you plus this one over here, you got 55. Yep. So that's going to be the same when you have the sum 2019. So if you use 2019 divided by 9, what do you have? You're going to have this 224 with the remainder 3, right? Make sense? And the remainder means you have to put that at the very beginning of this number. So you have a 3 followed by 224 of 9s, right? And that will be the smallest number you can have. If you add all the digits together, that will be 2009. And the question is, what is the last digit of that number? Then it's just 9 over here. So you choose E. Does it make sense? Now, Yep. Okay. And then next one. So Joy calculated the sum of the largest and the smallest 2-digit number that are multiple of 3. So I guess this one is very easy. You just write down that number. So the largest 2-digit number multiple of 3 will be 99. And the smallest 2-digit number that are multiple of 3 will be 12, right? And then Zoe calculated the sum of largest and smallest 2-digit number that are not multiple of 3. If that is not multiple of 3, then you have this 98, right? That's the largest number, which is not multiple of 3. And of course, the smallest one of 2-digit number will be 10, which is not a multiple of 3. The question is, what is the difference between the answer? So you do the sum of these two, right? Take away the sum of these two. So 99 is 1 larger than 98. 12 is 2 more than 10. So the answer will be 1 plus 2. You got a 3 over here. So you choose B. Okay. Next one. Next question. So 2 of the following 4 facts about the positive integer n are true and 2 are false. Okay, guys. The first one says n is divisible by 5. The second one, n is divisible by 11. N is divisible by 55, guys. If the third one is true, then the first 2 will be true at the same time. So that means the third one cannot be true, because in the question tells you only 2 of the facts are true and 2 are false, right? So that means this number is not divisible by 55. But as for this 2, we cannot tell so far, right? So we're going to start from the last one. Let's say if this one is true, can we find the number? So if that number is 10, you see out of all the 5 options, 5 is less than 10. And is that 5 meet any requirement? As for the first 2, you're going to see the first one, 5 is divisible by 5. And also 5 is not divisible by 11. So this one is not true. And the first and last one is true. So that's why the value of n is 5. Because that's going to meet the requirement, right? Okay, next one. Which of the following is divisible by all of the integers from 1 to 10 inclusive? And let's see, because that number 5 is really special, it end with 5 or 0. So you can just eliminate the first one because it's not divisible by 5. The last digit is 2. And also this one is not divisible by 5 because 7 times 8, the last digit is 6. It's not 0 or 5. And also this one is not divisible by 5 as well. And then, guys, you have to compare these two. You have to compare these two. And for this one, you can do the prime factorization. If you divide by 2 of 34, you're going to have a 17, right? And then you times by 5 times by 9. Sorry, it's 9, not 3. And you see that B is not divisible by 7, and also it's not divisible by 4, right? It's not divisible by 4 and 7. And also it's not divisible by 9. I mean, divisible by 8. So this one, you cannot choose that. And for this one, you see 57 is divisible by 4, 8, 7. And that means 3 is also divisible. So we choose C. That's the correct answer to this one. Okay, next question. So Thompson writes down 3 two-digit integers. One is square, one is a prime, and one is triangular. She uses the digits 3, 4, 5, 6, 7, and 8 exactly once. Which prime does she write? So let's see. I'm going to list all the square numbers meet this requirement. You see that from 3 to 8, you don't have 1, right? So you can have 16. And how about 25? We don't have a number. We don't have a digit 2, right? So you don't have 25. And as for the square, we can have 36 because we have 3 and 6. We do have 36. And then next one, 7 times by 7, you got 49, right? But you see, out of that 6 digit, we don't have 9. We have 3 to 8. So 49, you don't need to list that. Don't need to list that. And then 64, we have that. 81, we don't have a 1, right? We don't have 1 to use. So as for the square numbers, we have only 2 choices. And then let's take a look at the prime numbers. And as for prime, guys, prime numbers, you see, it must be an odd number. So it must be end with 3 or 7, right? So let's list all these prime numbers end with 3. So you have 43, it's a prime number. And 53 is a prime number. 63 is not a prime number. 73, yes, it is a prime number. And 83, it is a prime number, right? And of course, you can end with 7 to get some prime numbers. 37 is a prime number. And 47 prime number. 57, is that prime number, guys? Is this a prime number? Is that 50? No, it's not, because it's divisible by 3. So we don't have 57. And how about 87? 87 is still not a prime number, because 8 plus 7 is 15, right? And 67, yes, this is a prime number. And then let's list all these triangular numbers. Does anyone know what is triangular number? Okay, Kiki, can you tell us what is a triangular number?
Is it basically when you do 1 and then you add 1, which is 2, and then add 2, which is when you, so you use numbers that can like be made into like a triangle almost. So then 1's at the top and then 2 and 3 is at the bottom. So that's 3 numbers. Yes. And then you add another layer, which is add 3, which is 6. So
yeah, that's right. That's right. Okay, guys, basically, why do we call that list of number triangular? Is because the first one, you got a 1 dotted, and then you got 1 and another 2 just on it. So it looks like a triangle, right? And then you got 3 numbers, and then you got a triangle again by adding 3 more at the end, at the bottom. So the next triangular number will be 6. And then you see every time the first triangular number you have will be 1, right? And then you got a 2 and you got a 6. I mean, you got a 3 and you got a 6. So now I will list these triangular numbers for you. We have this 1, and then add 2, we got a 3. Add 3, you got 6. Add 4, you got 10. Add 5, you got 15. And then add 6, you got 21. And next one, 21 plus 7, 28. We have 28. 28 plus 8, you got 36. Plus 9, 45. Plus 10, 55. Plus 11, 66. Plus 12, 78. Plus 13, 91. And we're going to stop here because it's asked us for the 2-digit integers, right? And then, guys, we're going to cancel all the numbers that we cannot have because we only use digits from 3 to 8, right? So this one, you don't use it. 3, single digit. 1, we don't have 1. We don't have 1. We don't have 1. And also we don't have 1. 28, we don't have a number 2. 36, I'm gonna leave it here. 45, yes. And 55, nope, you can only use a digit by one time. 66, nope, cancel that. And now let's see, what do we have now? If we choose 36 as a square, you cannot use 3 and 6, right? Is that possible that we have some correct answers if we don't have 3 and 6? If we have 3 and 6. Okay, guys, if you got 3 and 6 for the square, that means as for the prime, you cannot use 3 and 6 anymore. So that means you can only got this 47 as your prime, right? This one. And that means we have this 5 and 8 left over. And you will see that no matter 55, no matter 58 or 85, the both are not triangular numbers. That means the square number, we cannot choose 36. It must be 64. And since we use 6 and 4, so you cannot have this number as the prime. So what's next? Let's see, 6 and 4, you cannot use that. So the only prime you can have will be 37 or 73, right? But you see that if you use 37 and 73, it's not possible. You get a triangular number. So we're going to start with triangular. If you use 6 and 4, so this 36, you cannot use that as triangular because you have already used 6, and 45, we cannot use that. So that means you have only one option for this triangular number. That will be 78. So we can cancel out this 7 and 8. That means as for the prime, you can only use 3 and 5. So 3 and 5, 35 is not a prime number. So that must be 53. Okay, and that's it. So the square 64, triangular 78, and the prime 53. So we choose C over here. Does it make sense, guys? So as for this one, I hope you can learn what is triangular number. You're going to start with 1, and every time you add 2, 3, 4, 5 to get the next one. Okay. So next question. It says the first and the third digit of the 5-digit number are the same. If the number is exactly divisible by 9, what is the sum of the 5 digits? So when we talk about the divisibility rule for 9, you have to add all the digits together to make it divisible by 9, right? So let's see if we add all the digits, what do we have? You got 2D plus 6 plus 4 plus 1, that will be 11, right? And let's see, if you want to get a multiple of 9, you can only choose either 18 or 27, but which one is correct? If this one equals to 18, guys, that means 2D equals to 7, and then D is not an integer. and giving me a decimal number. So this one is not good. And now we can try 27. Is that correct? Of course, guys, in the exam, you can just choose D, okay? But here, I'm going to prove that is 27. So 27 take away 11, got 16. Then 2D is 16, then D equals to 8. And you find the answer. So that will be D over here. It asks you the sum of the 5 digit. So that'll be 27. Next one. So for this one, it's the counting method. You need to count how many black squares that we have in each pattern. So the diagram below shows a sequence of shapes made up of black and white floor tiles, where each shape after the first has 2 more rows and 2 more columns than the one before it. How many black tiles would be required to create the 15th shape in the sequence? So at first, we need to figure out, as for some shape, how many of squares do we have in total, right? You see, the first one, you have only 1 square. And the second one, we got 3 by 3 squares in total. And the third one, how many squares that we have? We have a 5 by 5. Yep. What's the relationship between 1 and 1, 2 and 3, 3 and 5? You know that next one will be 4, right? And you got 7 by 7, because every time you're going to have 2 more columns, 2 more rows. So basically, as for the number here, first one, second one, third one, fourth one, you have to times that number by 2 and take away 1 to get the length of the tile. So as for the 15s, you do 15 times by 2 minus 1. And that will be 29. So that means as for that one, you're going to have a 29 by 29 shape, a square, right? And out of that one, how many blacks do you have? You see that the first one is a 1 black, second one is 5 black, and basically the black, if you cut it here, is this part, you got 1 black, 1 white, 1 white, 1 black, 1 black, 1 white, right? So it tells you that the black and the white will always be the same on the left-hand side of this vertical line that I draw for you, right? And on the right-hand side, you see that you got 2 blacks and 1 white. So black will be 1 more than the white. And if you take a look at the third one, that will be the same. If we cut it here, black, white, numbers are the same. White, black, numbers are the same. Right? If you continue that to the end, you know the number of white and black will always be the same. And then you compare the last column, the black will be 3 and the white will be 2. That means black is 1 more than the white. So guys, that means always you have 1 more black than the white. Okay. So as for the 15th one, how many small squares do we have in total? That will be 29 times by 29. Okay, guys, can anyone tell me what's that number? Can anyone tell me how many squares do we have? If you do 29 times by 29, what's that number? 841. That's right. We have 841 squares. And because you have 1 more black, right? So what if we just take away that 1 more black? We got 840, right? That's the number of black and white, and they equals to each other. So you divide it by 2. You get 421 blacks. And you just add 1 more black. Sorry, to 420, not to 421. If you divide by 2, you got 420. That's the other blacks except that 1 more, right? So as for the total number of blacks, you got 420 plus that 1. So that will be 421 blacks. So we choose B. Okay, guys, does it make sense? Can you tap 3 if you understand the question to me? Yep. Very good. Now let's take a look at this one. Stephen subtracts the unit digit from the tens digit for each two-digit number. He then finds the sum of all his answers. What is the value of Stephen's sum? As for this question, guys, the first two-digit number will be 10 and the last one will be 99, right? So it's like you have to add all the unit digit from 10 to 99 and then use all the sum of the digit at the tens digit to take away that to find the difference, right? So guys, as for the tens digit, can anyone tell me how many of 1 do we have? How many of 1 do we have? Tens digit. Can you type your answer in the chat box, guys? How many of 1? You're gonna go start from from 10 to 19. Yes, from 10 to 19. How many of 1 do we have in the tens digit? You have 10 of 1, right? In the tens digit. And also that will be the same for number 2, for the digit 2 in the tens digit. You're gonna count from 20 to 29. They're gonna be 10 of 2 as well. So basically, as for all the digit in the tens digit, for all the numbers in the tens digit, you have 1 times 10 plus 2 times 10 plus 3 all the way to 9 times by 10, right? So let's put that common factors together. So you do 1 plus 3, 2 plus 3 all the way to 9 and then times that by 10. That's the sum of all the tens digit. Make sense? Yep. So far so good. And let's take a look at the unit digit. As for the unit digit, you're gonna start from from 10, right? How many 0 do we have, guys? We have 10, we have 20, we have 30, all the way to 90. So we have 9 of 0 in the unit digit. And then how many 1 do we have in the unit digit, guys? You have 11, 21, 31, 41, all the way to 91. So also 9 of that. And then you're going to find the pattern. As for 9, you have 19, 29, 39, all the way to 99. So it will be 9 of that. Okay. And if we put them all together, it will be 0 plus 1 plus 2, all the way to 9 times by 9. Now, guys, can you tell me what's the difference of the tens digit and the unit digit? It's 1 plus 2 plus 3 all the way to 9 times by 10. Take away 9 of that. So basically, the difference is just 1, 2, 3 all the way to 9. So just remember this equals to 45. If you don't remember that, you can use the formula to get the sum, which is the first term plus the last term times how many terms that you have, and then divide by 2. So 90 divided by 2, you got 45. And that's the difference. And also the answer to the question. So it should be. Actually, the correct rate for this one is only 36%. So guys, if you did this wrong, take the notes and correct it after the class. Okay. And then this one. As for this question, you see you got 2 numbers that are known. It's like a number puzzle, right? 2 numbers times together. One of that is a 3-digit number. Another one is a 2-digit number. If you times them together, you got 7,632. And for this multiplication, they're going to use each of the digit from 1 to 9 exactly once. What is value of B? So basically for this question, for such kind of question, my suggestion is that you just list all these 9 numbers first. 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's see, as for the product, we have already used 7,632. So you just cancel that. You cannot use that anymore. So 7, 6, 3, and 2, we cannot use that. And then you see you got 2 numbers to be determined, right? So let's see what's going to be the numbers times together to get this one to 7,632, guys? You have to make the prime factorization of this number. So 7632, that's the most common way we use to solve such kind of a problem. So this one is divisible by 2. If you divide by 2, you got 3, 8, 1, 6. And then it's also divisible by 2. So we got this 1,908. So divided by 2 again, you got 954. It's also divisible by 2. We can have this 477. And after 2, you see this number 477 is not divisible by 2, right? So you can use this number divide by 3. 4 plus 7 equals to 18. It is divisible by 3. So let's divide by 3. And we're going to have this 159. 1 plus 9 is 10 plus 5, 15. It's also divisible by 3. And if you use that number divisible by 3, what do we have, guys? Can you type your answer to me? 159 divided by 3 equals to 53. Yes. So, guys, 53, is that prime number? Is that prime number 53? Yes, it is a prime. So we're going to stop here. We just finished the prime factorization of 7,632, right? I got a question for you. Could that DE be 53? Yes or no? Could that DE be 53? Nope, guys, because you cannot use 3 anymore. You just cancel that, right? So because DE cannot be 53, that means ABC must be a multiple of 53. Am I right? So ABC must be a multiple of 53. And let's see, if we do 53 times by 2, you got 106. Can we take this number? Do we have 0 to use? No, we don't have 0. Can we have 53 times by 3? Yes or no? That will be 159. And you say, yes, we have 1, we have 5, and we have 9. Let's cancel that. And that way, you have 4 and 8 left over for you. And guys, if we do 53 times by 3, means for all the factors, we can use this one and this one. We have already used 1 of 3 and 1 of 53. And if we times all the other factors together, what do we have, guys? 2 times 2 times 2 times 2 times 3. What's the product of all the other factors? 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. 16 times by 3 got 48, right? And you will see that is perfect because we only have 4 and 8 left for us to use. And it's just that 2 numbers, 48. So guys, you just solve the question. That will be 159 times by 48. Question is, what is B? Then B equals to 5. So you choose C. Okay, guys, are we all good? Should I move on? Can you tap 2 this time if you think we can move on to the next one? Yep. Everything clear? The next question, a palindromic number is a number that reads the same when the order of its digit is reversed. What is the difference between the largest and smallest 5-digit palindromic numbers that are both multiple of 45? Yes, if a number is multiple of 45, that must be a multiple of 5 and 9 at the same time. And also you got 2 5-digit of that. Okay. And as for the smallest one, guys, we know that for a number which is divisible by 5, the last digit must be 5 or 0. But can we have 0 in this question at the last digit? Nope, because it's palindromic, right? If you got 0 at the end, that must be 0 at the very beginning, but you cannot have 0 at the beginning of a number, right? Of a 5-digit number. So it must be 5 at the end. So this will be determined, this will be determined, and also this too, 5, 5. Let's see, this is the smallest, and the next one is the largest. Small, large. So as for the smallest, it must be divisible by 9 now, right? Because we have already make sure that it's divisible by 5. So you have to meet the requirement that is divisible by 9. And then if a number is divisible by 9, you have to add all the digits together to make it divisible by 9. So as for the smallest, 5 plus 5 is already 10. And the next multiple of 9, which is larger than 10, will be 18, right? So that means you need to determine 3 numbers add up to 18 and to make that as small as possible. So the way will be 0, 8, and 0. Yep, makes sense. And now, if you want to get the largest one, guys, we already got 2 of 5. So can we get 27? Can we get 27? So 27 take away 10, you got 17, right? You got 17. And if you want to make it as large as possible, so it means we need to get this digit as the 9. So 9 and 9. But if you do so, 5 plus 9 and 5 plus 9, that'll be 28, which is larger than 27. So that means we have to go to the next multiple of 9, which is 36, right? That means you add all the digits together, you got 36. So what's the number in the middle? 36 take away 5 and 5 and 9 and 9. Basically, you take away 28. And that will be 8 in the middle. And now you just solve this, you just find these 2 numbers. One is 50,805. Another one is 59,895. And the question is asking you, what's the difference of that 2 numbers? It's pretty easy to do the calculation. It's just the 9090, right? 9,090. If you use the second one, take away the first one. So we choose B. That's the answer over here. Okay, guys, that's it for this one. And let's take a look at the next question. This one is from 2022, just last year question. The non-zero digit P, Q, and R are used to make up the 3-digit number P, Q, R and the 2-digit number Q, R and 1-digit number R. The sum of these 3 numbers 912. What is the value of Q? Guys, in our autumn term lesson, all of you learned this before. It's about number puzzles. You convert a vertical one into a horizontal one. Then you're going to solve the question. So you have PQR plus QR plus R equals to, say, 912, right? So in our long-term courses, we know that we can convert that into a vertical one. I mean, into a vertical one. So that will be PQR plus QR and R at this place. And you just add them all together. It's a columnar calculation. You got 912. Okay, guys, 3R equals to 2. Give us a 2. So what number times by 3 end with 2? You have only one choice for that. It must be 4. Because 4 times by 3, or 4 plus 4 plus 4 equals to 12. So you add 1, you carry over 1 to the 10th digit, and you see that it's just 1 at the 10th digit. That means Q plus Q equals to 0. But we know that Q, is that possible Q equals to 0, guys? It says non-zero, guys, at the beginning. Non-zero digit. So Q cannot be 0. Then which 2 numbers add together? The last digit is 0, guys. It's 5. 5 plus 5 got 10. Okay. So Q equals to 5 now. And then P, because you carry over 1, then P equals to 8. 8 plus 1, you got a 9. And that's the answer. Q is 5. We choose C. Are we good? Yep. Easy. Next one, how many 3-digit numbers are equal to 34 times the sum of their digits? As for this one, you have to use the the knowledge we called place value. We're gonna set that number as ABC. So it's a 3-digit number, right? So how can I write the value of that number? That will be, because A is in the hundreds place. So the value of the number equals to 100 times A, and then plus 10 times B and plus C. That's the value of this number over here, ABC. You know, it says this number are equal to 34 times the sum of their digits. So 34 times the sum of all the digits will be A plus B plus C. Okay. And this is what we have now. We need to remove the bracket and just simplify this equation, see what we have. So 34A plus 34 times B and plus 34 times C equals to 100A plus 10B plus C. You can take away that 34A from 100A, you got 66 times by A, and that equals to 34B, take away 10B, you got 24 times B, and plus 34 of C, 34 take away, of C, take away 1 of the C, right? So you got 33 of C. Guys, question, 63, 24, 33. Do they divisible by some number? So we can simplify that. Yes, they are all divisible by 3. So if you divide by 3, you got 22A equals to 8B plus 11 times by C, right? And since we find that 22 and 11, they got the common factor, which is 11. So we can move that 11C to the other side. And that way, we're going to have a 22A C minus 11C equals to 8B. Equals to 8B over here. And you can extract that out 11. So 11 times 2A minus C equals to 8B. Okay, guys, question. 8 times a single digit is a multiple of 11. Is that possible? 8 times a positive integer, or 8 times an integer equals to a multiple of 11. A single digit times by 8, you got a multiple of 11. Is that possible? Nope. Or yes? Guys, B could be 0, because we know that 0 is divisible by 11. That's the only choice that we can have over here, right? You got it? So that means B must be 0. If B equals to 0, that means this part will be 0 as well. So 2A minus C equals to 0 means what? Means 2A equals to C. In other words, C is 2 times of A. So how many different combinations do we have? As for A, B, C, as for this number over here, B is 0, so the 10th digit must be 0. And we know that the 1st digit will be 2 times of the hundredths place. So you have 102, 204, 306, and 408. That's it. That's all the combinations that we can have over here. Yep. So we choose E. It asks you how many of this that we have. So we have 4 of such numbers. And that 4 will be 102, 204, 306 and 408. Okay, guys, that's it. And then next one. Sonia wants to write a positive 5-digit integer whose digits are 1, 2, 3, and 4 in some order. The first digit of the integer is to be divisible by 1. Then the first 2 are divisible by 2. First 3 divisible by 3. First 4 divisible by 4. And first 5 is divisible by 5. So let me list all the 5 blanks for you. 1, 2, 3, 4, 5. And since this whole number is divisible by 5, that means the last digit must be 5. And now what do we have? You see the first 2 that is divisible by 2, that means this one must be an even number, right? And the first 4 is divisible by 4. That means this one is also an even number. So far so good, guys? So that means how many choices do we have? It could be either 2, 4 or 4, 2, right? And let's see, take a look at the first one, first scenario. If we do 4, 2, 4, and the first 2 digit is a multiple of 4, that means this 2 digit must be divisible by 4. And you only have 1 and 3 to choose, guys. Tell me, is that 14 divisible by 4 or 34 divisible by 4? No, none of them. None of them are divisible by 4. That means you cannot choose this order. We need to choose the second order, 4 and something 2, right? Because you see that 12 is divisible by 4 and 32 is also divisible by 4. But the first 3 digit must be divisible by 3. If you choose this one, second one, you need to do 1, 4, 3 or 3, 4, 1, right? In the order. But guys, if you add 1 and 4 and 3 together, is that divisible by 3? Is that divisible by 3? 1 plus 4 plus 3 equals to 8. It's not a multiple of 3, guys. That means it is not possible to have such kind of number using 1, 2, 3, 4, 5. Meet this requirement over here. So that's why the correct answer is 0. There's none of that number, 5-digit integer. Could Sonia write? Does it make sense, guys? Are we all good? Okay, last one. Last question today. The whole numbers from 1 to 2016. Cindy, which one you don't really get it? You mean this question or the previous one? Do you mean this one? What was the answer to the this one? Okay, Cindy, can you tell me why do you think it's confused? It's confusing.
It's like, when you like write down the 5 all of the 5 like letters thingy, and then you write down 5, I don't get like why it's like 2 like 4 and 2 like that part, and then why it's like 1 and 3.
Oh, because you can only use 1, 2, 3, 4 each number by only one time, right? And it tells you that the first 2 digits must be divisible by 2. That means this place. So this place, it must be an even number. Here,
Okay.
it must be an even number. Also, this one must be an even number because the last 4 digit is divisible by 4. All the multiple of 4 are even numbers, right?
Yeah, but why can't it be 2 and 4? Why is it like 14? Like there's 4 and 2.
Oh, okay. So basically the thing is that if a number is divisible by 4, the last 2 digits of that number must be divisible by 4.
Oh yeah.
Yep.
Okay, yeah.
And you see that if I do 4 over here, 14 is the one of the option, but it's not a multiple of 4, and also this one is not. So that means it's not possible to get a number of, a multiple of 4 as for the first 4 digits. Yeah.
Oh yeah, I get it. Thank you.
Okay,
Yeah.
good. And let's see this one. We write the whole numbers from 1 to 2016 inclusive, and they are written on the blackboard. Moritz underlines all the multiple of 2 in red, all the multiple of 3 in blue, and all the multiples of 4 in green. So how many numbers does Moritz underline exactly twice? Actually, guys, to solve this one, you can use the Venn diagram. So I'm going to draw a circle. Let's draw a circle here. This means all the multiple of 2. This is all the multiple of 2. Okay, guys, can anyone tell me where should I draw the circle that represent all the multiple of 4? Where should I draw that? Should I draw like this? Multiple of 4? Mina?
So all the
If a
multiples
number is multiple of 2, that means it must be
a multiple of 4 as well.
no. So it should be if a
It has to be
multiple.
above the multiple of 2.
Yes, that's right. So if a number is multiple of 4, that must be a multiple of 2. That means the
Multiple of 3 is
the
beside
multiple of 4 should inside the multiple of 2. Am I right? Does it make sense, guys? So all the numbers, which is a multiple of 4, it must be a multiple of 2. Make sense? So far, so good. Do you know the Venn diagram? So this green circle is the circle who represents all the multiple of 4, and that should be a part of multiple of 2. Any questions do you have? If you understand this, give me number 1. Yep. If you feel confused, give me number 2.
I put 0.89 because I understand it, because I don't really understand it.
So, okay, guys, so far we got this Venn diagram for multiple of 2 and 4, right? And now we need to draw the circle of multiple of 3. And you see, as for that 3, use the blue run. Okay, guys, the lesson will end in like 5 minutes because this one is the last question. So, because for the multiple of 3, you can use this circle to represent it. Multiple of 3.
That's a unique Venn diagram.
We do not talk about that.
Because the answer is not E. And why do we draw this multiple of 3 like this? Because some of the numbers which is multiple of 3, it cannot be multiple of 2, right? So you need to have some part outside that right circle. And also you need to have some part which is multiple of 4, 2, and 3 at the same time, but we don't count that. So the thing is that we need to get the number of this part. Right? And also this part. And this 2 pink part is a multiple of 4 and 2, but not a multiple of 3. because that two part is the numbers will be marked by two lines, which is the red one and the green one. Okay, and also you need to count the number in these two places, and that will be the number. You mark that by the red color, or the red line, and the blue line. Means it must be a multiple of 2 and 3 at the same time, but not a multiple of 4. Okay, so how do we get that? You need to find what will be the multiple of 4 and 2, but not a multiple of 3. So you have to find all the multiple of 4 in that 2016. So in 2016, how many of multiple of 4 do we have? You need to use that number divided by 4, right? So you got 504 numbers that are multiple of 4. And you have to take away multiple of 4 and 3 at the same time. So basically, you need to take away how many numbers are there, which is multiple of what number, guys? You need to take away, which is the number in the middle. You have to take away that part because you don't count that part. But what's the number in the middle? So the number in the middle means that number is a multiple of 4, 2, and 3 at the same time. So what's going to be the lowest common multiple of 4, 2, and 3, guys? It's 12, right? So you have to take away all the numbers that is multiple of 12. But how many of that do we have in 2016? You have to use 2016 divided by 12. You're going to have this 168 numbers that are multiple of 12. Multiple of 12, you have 168 of that. And sorry, it's 12. And also multiple of 4, we have 504 of that. And then, yes, you have to use this 504 to take away that part. So that will be this two shaded part, this two. So how many numbers are there in these two parts? That will be 504 minus 168. So guys, tell me what's that number? $336. Yep. Okay. And now you need to get how many numbers are there in this two part. So that is the number which is multiple of 3 and 2 at the same time, right? And then take away all the multiple of 12 because you don't count that number in the middle, because that number in the middle will be the numbers will be marked by 3 times. You only need to find the numbers marked by 2 times, right? Exactly twice. So let's see how many of multiple of 6 that we have. Multiple 6, you need to use 2016 divided by 6. What's the number? What is 2016 divided by 6? 336, right? We got this much of numbers that is divisible by 2 and 3 at the same time. But you have to take away. You have to take away the multiple of 12 because we don't count that, right? From this one. So also, and we don't need to do the calculation because we already got that, which is 168. So as for the numbers in these two part, in this two shaded part, that will be 336 minus 100 minus 168. And you got one number, 168, right? So how many numbers do we have in total that will be marked exactly twice? It's the sum of these two. It's the sum of these two. And you'll find it's 504. So we choose C. Guess that's it. The last one is kind of a hard question. Yeah, it's complex. Okay, that's it, guys.